So here is another question on representation of binary numbers, signed binary numbers in different forms. So here we have to represent minus 25 in sign magnitude, 1s complement and 2s complement form. Okay, 8-bit format. So first is the sign magnitude form. So first, in order to represent minus 25, first we have to represent plus 25. So the first step is split it into different parts with different powers of 2, with different weights. Okay, so here we can split it as 16 plus 8 plus 1. 16 plus 8, 24 plus 1, 25. So here 16 is 2 to the power 4, this is 2 to the power 3, and this is 2 to the power 0. So we have 2 to the power 7 because 8-bit format, so 2 to the power 7, 2 to the power 6, 2 to the power 5, 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, to the power 0. So all these positions, they will have 1 bit and the remaining it will be 0. So 2 to the power 0, there is a 1 bit here, 2 to the power 3, there is a 1 bit, and 2 to the power 4, there is a 1 bit. Remaining all are zeros. So the binary representation in sign magnitude form of plus 25 is 0 0 0 1 1 0 0 1. So here if you see the MSB bit, which is the sign bit, it is 0, so it denotes a positive number. Okay, so it denotes a positive number. Then this is plus 25, so minus 25 will be represented with the sign bit changed to 1. So minus 25, it will be this MSB bit, it will become 1, and remaining all magnitude bits, they will stay the same. Okay, these magnitude bits, they will stay the same, that is 0 0 1 1 0 1. Okay, 1 0 0 1 1 0 1. Okay, so this is the representation of minus 25 in sign magnitude method. Next is 1s complement. One is complement method. So in 1s complement method, plus 25, it will be represented in the same way as in sign magnitude, that is this 0 0 0 1 1 0 0 1. Okay, this is plus 25, same, but minus 25 will be represented as the 1s complement. 1s complement of plus 25. That is, we will invert the 0 bits to 1 and the 1 bit to 0. Okay, so it will become triple one, double zero, double one, single zero here. 1 1 1 0 0 1 1 0. This is minus 25 in 1s complement form. Okay, then is 2s complement method. So 2s complement method is we will add 1 to the LSB of the 1s complement. So this is the 1s complement. So we will add a 1 bit to the LSB. Here I am not writing it again. So okay, let me write it again. Okay, so 1 1 1 0 0 1 1 0. Okay, so here we'll add a 1 to the LSB, so it will become 1 1 1 0 0 1 1 1. This is the 2s complement representation of minus 25. So this is minus 25 in 2s complement form. Okay, now here you can also use the shortcut method. So here you have to start with the, I'm going here, okay, this, the representation of plus 25, that is this one. I'm writing it again here, which is 0 0 0 1 1 0 0 1. So here we'll start from the LSB side until we arrive at the first 1 bit. So here the LSB bit itself, the starting bit itself is 1. So we'll keep that as it is, because there is no any other bits behind it, no 0 bits behind it. So the first bit itself is 1, so we'll keep it as it is, and the remaining bits we will take the 1s complement, will invert them, that is 0 will become 1, 0 will become 1, 1 will become 0, 1 will become 0, and these 3 zeros will become 3 1 bits. So 1 1 1 0 0 1 1 1. This is the 2s complement representation of minus 25, same as what we have done here. This is the shortcut method. 1 1 1 0 0 1 1. Here also 1 1 1 0 0 1 1. So you can use the shortcut method. If you are not able to remember that, you go with the usual process. Okay, first calculate the 1s complement and then add 1 to the LSB of the 1s complement to get the 2s complement. Okay, so this is the thing.